Here we have our design view for tic-tac-toe, and this is what the user interface will look like. And then when we switch over to code view, we can take a look at what's going on behind the scenes. So as you can see here, we have plenty of functions to get this thing to actually work. So quickly going through them, we have our game loop, which updates the moves of the players. We have a take turn function. We have the start game function, set game state, reset game state, and all of these are what's ensuring that the actual tic-tac-toe game is going on. Enabling board and disabling board functions. Here we are creating our robot. We also have a draw grid, draw X, and draw O function, and move robot to, which moves our robot to those designated spots to draw the grid X and O. We also have a function for initializing our Arduino and moving the pen up and down, and of course, moving our servo motors. We also have plenty of properties here for our joint angles, our Arduino, servo motors, and other things. That's a little bit of the behind the scenes of what's going on. Here we see that we have our grid. We have game type drop down. So if we choose UI only, then we're simply playing a game of tic-tac-toe on here. If we click on simulation, then when I click on a grid, our simulated robot will show up. We also have full robot, which requires connection to our Arduino. This will move the robot in simulation and on the physical robot. We also have drop-down menus for players 1 and 2, and this could be human, GPT, or Bard. We have a reset button when the game's over. Over here in the info box, we will see who wins. As we can see, we're not currently connected to our robot GPT or Bard, but if we were to do that by clicking on here and making sure everything was connected, then these should light up green. Over here, we can see whose turn it is. Let's go ahead and start with simulation game type, where both players are human. So as we can see, when we press simulation, we had our simulated robot pop up, and here it is creating our grid for our tic-tac-toe game. Here we see the grid points that were plotted. The simulated robot and both the physical robot, when plugged in, are going to connect these grid points. And now, if I click over here for X, we see that the simulated robot, we clicked O, it would also move to the specified position and draw an O there in our simulation. Let's make this a quick game. And we can click reset to start over, and we can change the game type. Next, we can change it to full robot and see what goes on there. So as soon as we hit play, our physical robot draws our grid, and this is actually pretty sped up. It's about 4 times as fast as it would be in real life. And after that, we begin. We had a little problem with our motor, which is why there was a little bit of that lag. And now the users are choosing their moves, and the robot is moving accordingly. For this last X, it'll be in normal speed just to get an idea of how fast the robot is actually moving. And from this, we can tell that user 1 or player 1 is going to win, which is what shows up on the info box. And then this clip shows the pen moving on and off the clipboard. And for our AI match, we have ChatGPT for Bard, and this is 2 rounds. And when we press play, we can see that the board is disabled and they're doing their own thing pretty quickly, but they do make some invalid moves. So when that happens, a random move is selected, and this does change the probability of, ChatGPT versus Bard winning. So that was something that we also have to take into account in the future.